My name is Nati Cohen. I'm a specialist solutions architect for compute in AWS, which means that I help customer use compute efficiently in the cloud. It can be a lot of things like choosing the right instance type, utilizing AWS spare capacity, also known as spot instances, and specifically for this talk, how to utilize AWS Graviton, which is our ARM64 processor. In case you missed the thing that is slowly changing in data centers in the last few years, it is not just an x86 world. Like we used to be in a situation where our entire data center was x86 servers, but then slowly, starting from people's home with this tiny device over here, people started installing Linux on ARM64, installing the applications on ARM64, and starting to do cool things with it. And then developers started getting developer laptops with Apple Silicon, and so another place where ARM64 found its way to. Finally, in the last, I think, 5 or so years, maybe a little bit more, we have ARM64 VMs in the cloud. In AWS, it's AWS Graviton, but in all, I think, big hyperscaler today, they have their own ARM chip, or they buy an ARM chip from a third party. And you're probably asking yourself, okay, we understand another CPU architecture, but why should I care? There are several reasons. Maybe the first one will be enough for you. ARM processors usually draw out less power, require less cooling, and so are cheaper to run. They can also deliver better performance if you are right-sized in your CPU workload, meaning that you are being able to use all the CPU cores on your instance. So you can drive better performance on ARM64. They improve sustainability, which is an important part for some companies. And they can also help you support your customers, be it internal customers like your developers who want to have their local development environment. They want to run the container images on their laptops, for example, or your external customers who wants to run your application on ARM64 somewhere else, right? So the way I structured this presentation is around customer questions. So the thing that I find myself talking with customers about. Maybe one of the first questions customers ask is, okay, this is a different CPU architecture. What does it mean, right? Different CPU architecture means that our code that we write is going to get compiled into a different machine code when we run on x86 and when we compile to ARM64, right? And this is a very naive example, taking a C code and showing how it looks like on x86 assembly and on ARM64 assembly. This means that if we have any executable binaries or shared libraries that are compiled into binaries, we need to have them for ARM64 and we need to have them for x86, right? And the good news are that for data types, we don't need to do anything, right? Because for ARM64, data types are the same size, NDNS is the same, like the order of bytes in data structure is the same. And so we don't need to migrate data when we move from a system that's running on ARM64 to a system that's running on x86 or vice versa. In terms of our stack, we do have binaries, executable binaries or shared objects in a lot of places in the stack. And so if we are running a hypervisor, we need this hypervisor to be able to run on ARM64. And we need our operating system to be compiled for ARM64 because there is a kernel in there and a bunch of libraries and binaries. Our container images are essentially executables with all their dependencies. We need container images for ARM64. Libraries and frameworks are also compiled stuff. We need them for ARM64. And our application, well, it depends, right? If our application is interpreted or JITted For example, you have a Node.js application, you are most likely not referring to the CPU application, the CPU architecture anywhere. So you can take the same code and run it on ARM64. If your code on the other end is C, C++, and you have some specific optimization for the architecture that you're running on, you might need to do some changes. And we'll talk about it. The next questions customers ask is where should we start, right? We have a lot of things running on compute. What are the most easiest parts to start with and show maybe value, and then where should we move from there? And so I like to divide this into 3 parts. The first one is software someone runs for you. The second is software that you run. And the last one is software that you build and run yourself. So software that someone runs for you, you refer here to what we call in AWS managed services. These are services that someone else is running for you. You don't have access to the operating system of that thing. But you might be able, you are able, in this specific case, to say, I want this to run on ARM64, or I want this to run on x86. The reason that this is, or maybe a few examples of these kind of things, in case you can't imagine such systems. In AWS, there are like managed databases like RDS. There are managed caches like Redis. It's called Elastic Cache. It has Redis, Valkey, and Memcached. There is managed Kafka, managed Elasticsearch or OpenSearch. It's also available in some partner offerings. For example, Elastic Cloud allows you to specify which kind of instance you want to run on. And so the reason that these are easy is because someone else already did the legwork of checking compatibility and saying, OK, you can use this specific version onward. Someone else already did the legwork of designing a migration path and testing that migration path. And so you mostly need to read the documentation. And someone is going to support you in case you are going to have any issues, right? The things that you are still going to own in this kind of place is performance testing and right sizing, right? So if you will see better performance, you might want to switch to a smaller VM or less VMs, right? Or less instances running in that service. And maybe a word on performance testing. So a thing that I saw happening repeatedly at different customers is that they are not asking the right questions when they approach performance testing. And specifically, what I would recommend for you to do when you do performance testing in this specific case is to prefer realistic load tests. And by realistic, I mean something that kind of emulate the environment that you're going to run in. So don't load test with gets if you have half gets and half posts, right? And try to compare dollar per request or dollar per job, depends on what kind of application you're running, between these 2 environments, right? Of course, it will have to respect like all the other things. If you have a SLO for latency, everything should be under that latency, and the results should be correct. But the thing people tend to use here is look at CPU utilization, and CPU utilization is going to lie to you. And the reason it's going to lie to you, one, because it's a bad metric. We can take it outside if you want. But specifically in that case, you're going to compare 2 CPU architecture. x86 usually runs with SMT, or it's called in Intel hyperthreading, where you have 2 threads that are mapped to the same core. And this can be super useful, right? But the thing is that if you are well utilizing your CPUs, you will see some sort of a knee in the relation between your CPU utilization and requests per second, right? Or what other way you choose to measure work. However, in ARM CPUs, each vCPU that you see is a core, and so the relation is more linear. So this means, other than please don't try to compare CPU utilization. If you migrate, you might need to also adjust your scaling thresholds, right? If you are scaling based on CPU utilization, after migration, you might need to switch it like from scaling on 60% to scaling on 80%, right? Or scaling on another metric at all. One last thing about software someone runs for you. These will usually have a minimal version. This is the version that someone that runs it for you I've decided that it works from. That doesn't mean that this is the version you need to stick with. You should prefer to use newer versions. The reason is that newer version will have performance optimizations, which allows you to enjoy ARM64 better. And this is going to be a recurring theme along this talk, right? Always try and use newer versions because they will have both support and optimizations. Sorry. The next kind of software is the software that you run. And by that, I mean either open source stuff where you actually own the VM and you own the operating system. So think about your Spark clusters, Kafka, Cassandra, Elasticsearch or OpenSearch, Solr, Redis, MySQL, Postgres, all this fun stuff. And also things that you are running from third parties. So it can be like Elastic Enterprise, Databricks, Aerospike, ClickHouse, Couchbase. So all these softwares can also move to ARM64. They all support ARM64. But since you have more control and you are controlling the VM, you are controlling the operating system, maybe you are in an organization where you also have to install several agents inside these operating systems, you also have more responsibility. And these responsibilities include taking an OS that supports ARM64. So if you have like a really old, I don't know, if any of you have Ubuntu 16, maybe don't raise your hands, but using an operating system that supports ARM64 and preferring newer operating systems that also optimize for ARM64, specifically in the data center, right? So you would want to choose an operating system that, for example, uses LSE, right? Which is an extension of ARM64 that make logging fun. Next thing that you want is you want your runtime, if you have any control over it. So for example, if the thing you run runs on Java and you're still running Java 8, it will work on ARM64, but you will get much better performance if you are able to switch to using Java 17 or Java 21. And of course, the application version. And again, newer application version, better performance usually. Another thing that is in your responsibility here is the migration mechanism. So usually with this kind of software, you will have to decide how are you going to move from x86 to ARM64 and also think about a way of rolling back in case you're seeing something weird, right? And then you can fix it and then try again. And of course, all of that in addition to performance testing that we discussed earlier. And maybe with one more thing that you need to note, since you own the OS. So another thing that I've seen customers missing around here is that when they are migrating these kind of systems, they usually try to do multiple things all at once. So they say something like, okay, we're already moving to ARM64, let's already use newer operating system, and let's already move to Java 17, which isn't necessarily a bad idea if it works. But when it doesn't work, it makes debugging things a lot harder and identifying like what's going to give you problems here. And And so I would recommend less moving parts when you're doing these performance testing. Try to have your system under test as similar as possible, right? So similar kernel version, similar kernel flags, similar sysctl config and all that. And there is at least this open source project called aperf. It's being developed by the Annapurna folks at AWS. It collects perf metrics, but it also collects your system configuration. And so when you will compare the two, like in x86 and in ARM64, if you see weird things, you will also have the config right next to you. And so you will be able to tell maybe this might be the issue. The last kind of software is the software that you build and run. And since we said that in ARM64 we have different binaries, this means that you are going to have different artifacts usually. So for interpreted and JIT languages, as I said, it's going to probably be easier because you might not have to touch your code, right? In Node.js, you might not have to touch your code. In Python, you will most likely don't have to touch your code, but you might need to make sure that your dependencies, if there are native dependencies, support ARM64, which are pretty common in Python, having a native dependency. And in compile languages, we are usually looking for intrinsics, like we're looking for pieces of assembly code embedded that is utilizing a specific feature of that CPU architecture that you're running on. Native dependencies, by the way, can also be in Java. If you're using like JNI, you can find a shared library inside your jar. So you might also want to check for these. And the obvious question is how can we estimate how much work this is going to take? Like, okay, we have like lots of Python projects with lots of dependencies, with lots of versions. We have lots of Java projects. And in order to kind of get an estimation, there is this project called Porting Advisor for Graviton. This is a fork, from ARM's Porting Advisor that has rule-based. It can tell you things like, okay, in your, you will run it against your repo, and it will tell you, you're using these dependencies. This specific dependency doesn't support ARM64 in this version, you should upgrade to that version. Or it can tell you, I found intrinsics in your C code in that file. So this is pretty useful. Maybe something important to say here is that these kind of tools aren't hermetic. So they will help you get a general idea of the work, but they are not like 100%. 100% is building and running the thing. There are other forks of Porting Advisor. There is a new one from like a month ago called Migration Ease that also try to scan Docker files and Rust files for intrinsics. I wouldn't recommend it yet. It's not like fully stable, but maybe keep an eye out for other scanners as they come out. So we know that we need to create new artifacts. So this means that we need to update our CI/CD pipelines in order to build this ARM64 artifacts. One thing that people are kind of tempted to do is to use emulators in order to build ARM64 artifacts on x86 instances. I would highly recommend you don't do that. It might be easy, but here are at least my two reasons. First reason is that building or compiling inside an emulator is going to be slower. And if you're running in a cloud environment, this means more expensive. And the second reason is specifically QEMU has a tendency, at least for me, and I saw it also in multiple other customers, to randomly segfault. And now you have two problems. right? So the way to go is to have workers, runners, builders, whatever the terminology in your CI system that are running on ARM. And then it doesn't have to take double the time, right? The build can still take the same amount of time. So everything that happens before the build step, the actual build step, like unit testing, linting, security scanning, right? All of these can still happen for both architecture just once. And then once you want to build, you go into a parallel state, and then you build in parallel for the two architectures, and then every other test that you want to do that is binary specific, you will do in parallel. So this will take the same time. It will be a little bit more expensive because we need more compute. And yeah, this is the safer way to go. Another question that I get a lot is, should we build and run multi-arc? And there are some good reasons to build multi-arc and run multi-arc. To build multi-arc is, for example, during a migration phase, you want to be able to roll back if you find something. Building multi-arc will allow you to do that during whatever migration period you have decided on. Some folks are running in multiple different places, and so maybe in some cloud environment they want to run on ARM64, but on-premise or somewhere else they need also x86 version. And some folks are building software for customers, either internal or external customers, and their customers are running in different places, and so they need to support them. And so these are the reasons to build multi-arc. There are trade-offs, of course. So again, pipelines are going to be a little bit more expensive. There are some edge cases that you should be aware of. Most people, in at least the last amount of years, didn't really change the architecture of the runtime they're running on, or didn't make any big changes to the runtime they're running on. And so they might find themselves surprised with things. For example, most people don't know that Java math isn't bit-to-bit exact. And so if you're running calculation with Java math and you're trying to compare things that are far behind the floating point, they won't be exactly the same on different implementation of Java math. There is a solution for that. It's called strict math, but you should know, like, this is a thing, right? Otherwise, this is a surprise. So yeah, sharp edges you need to know about. Also, when you are running multi-arc, if you are seeing better performance, and again, this is not something that is special for ARM64. It's more about running in a mixed VM environment, right? Where some of your VMs are going to be more performant than others, right? You will need to find a way to balance the load between them and scale and decide when to scale. And so CPU percent might not be your friend anymore. So the next question is, what about containers? So not a lot. It's just a type of an artifact, right? This is where we put our executable thing and all of its dependencies. We will need one image per architecture, but the good news is that we can use something called an image index, which is essentially a tag in your repo that will point behind the scenes to multiple image container images. With a little bit of metadata, so platform metadata, it will say something like, you can also just open your laptops right now and do it, something like docker manifest inspect Ubuntu latest, right? And you will see that Ubuntu latest, for example, is an image index. And it points behind the scenes to multiple images and say, this is the image for Linux AMD 64, this is the image for Linux ARM64, this is the image for Linux another CPU architecture, right? And you can, of course, create these as part of your CI pipeline. Another thing that you want to do with containers is to use something called automatic platform args. And this thing will save you from having a Docker file per CPU architecture if inside the Docker file you're doing things that are architecture specific. So think about, for example, you are downloading the Golang binary, right? And so in the URL, it says like Linux x86, right? And so instead of having that hard-coded inside your Docker file, what you can do is use these arguments, and they will be automatically populated by BuildKit when you build. And so you don't have to manage multiple Docker files, which is fun. This question doesn't come up a lot, but it is interesting to know. So if you have a large Kubernetes cluster with a lot of container images, and you kind of want to gauge how much work you're going to have, this allows you to scan your Kubernetes cluster and then be able to say, OK, these are all the images I have in the cluster. These images already have like image index and have ARM64 options behind the scenes. These images have other tags with ARM64 options. And these images don't have any ARM64 in their repo. And so you will know how much work you need to do and which images you can, or which pods or deployments you can move first. OK, so in order to be completely fair, let's talk about reasons not to migrate to ARM64. So there are technical reasons and non-technical reasons. So let's start with the technical reasons for the technical people. So the first one is unsupported operating systems. So currently, there is no GA version of Windows Server for ARM64. There is Windows Pro 11 and Windows Server 2025 should be there eventually. We're all waiting, but it's not there yet. Arch Linux isn't there. If you have Arch in production, I'm interested. There are some unsupported runtimes, namely, I think an interesting one that I saw was MATLAB. So apparently people run MATLAB in production, and MATLAB doesn't run on ARM64. It does run on Apple Silicon with an emulator, but please don't run things on emulator in production. There are unsupported applications, usually not open source stuff, but more like vendor stuff, where they made, I guess, a business decision. So some examples I've seen recently are Tableau server or Splunk server. And then there are some places where they run on ARM64, but have specific features that aren't available on ARM64. So I've seen a lot of really happy Databricks customers that are running lots of Databricks workload on ARM64. But specifically, there is a feature called Databricks SQL that doesn't run on ARM64. So yeah, if you're going to move your things, go read the requirements and the manuals. There are non-technical reasons not to migrate. I'm not going to name names in this part. There are vendors where they have a different licensing scheme for specific CPU manufacturers, which will make this transition not worth it in specific places. So read your licenses. And also there are places where ARM64 might not be available for your deployment option. So there are vendors that have their product available as a SaaS solution and as an self-managed solution. And so they might have ARM64 available for one of them, but not the other. And you accidentally need the other, right? So these are not technical reasons because it works, but not for you. There are sometimes reasons to postpone migration. So while you are technically able to migrate, you might want to do some payment on your technical debt beforehand. And these can be like with old operating systems that don't have, for example, LSC optimization, first upgrade to a newer operating system. Or if you're using, for example, Java 8, Java 8 will work and you can move it. You will see more benefits if you move to Java 17. So you can decide if you want to do this before or after. But this is something that is worth doing. For example, another example is .NET Framework. So .NET Framework only runs on Windows. So you first need to move from .NET Framework to .NET Core, and then you will be able to run on Linux. And then you will be able to run on ARM64 because .NET Core runs great on ARM64. Microsoft also deliver Docker images for that, which is amazing. The good news is that this is the place to use AI tools, which is the theme of this SREcon. Shameless plug. In AWS, we have Amazon Q Developer. It has a transform feature, and it's trained on helping customers to move from .NET Framework to .NET Core and from Java 8 to Java 17 and Java 21. But I assume that there are others that you can use if you like them. Final step, optimization. You don't have to do this. You might be already happy, right? And you wish to stop. But if you want, one thing that you can do is right size after moving a CPU architecture. You might find that you took advantage of the better performance. And now it might be worthwhile to reconsider which instances you're running on. Maybe you want to change the ratio between the CPU and the memory. Maybe you want to use smaller instances. Maybe you can use less instances. And this will help you realize savings. Some people use the ARM performance libraries, usually when they're doing HPC stuff. These are ARM optimized mathematical functions that you can use. There is also the ARM software optimization guide that lists all the optimizations that you can get on the specific core type of the ARM processor that you're using. So for example, I worked with a customer who is doing a lot of SHA-1 calculations. And so we had a naive code written in C and compiled in GCC, and he compared that in x86 and ARM, which isn't really the best thing to do because you're basically testing how GCC is doing vectorization instead of testing like the specific CPU and its optimization. So when we switch to testing the same optimizations on x86 and the same optimization on ARM, then they saw like the better performance. So this will have the list of all the things that you can get in the core that you're running on. And if you're looking for a runbook, we also have that on GitHub, where it will guide you through like how to build a test environment, how to measure, what to look for, and how to optimize. So in summary, I would highly recommend you give ARM64 a chance. Most likely it will be easier and you will see the performance or the cost improvements really quickly. I think one takeaway from me doing this for a while now, this is getting easier for you, right? So there are more documentations, more tools, more dependency support, more application support. So this is a really good time to do that. And finally, when you do performance testing, and please do, make sure to ask the right questions and to isolate the testing that you do. Thank you so much.